The inverse cosine function. We start with y equals cosine of x graphed from negative 2 pi to 2 pi. And then we're going to reflect y equals the cosine over y equals x to get its inverse. Notice that this graph is not a function because it does not pass the vertical line test. So we don't yet have the inverse cosine function. So what we're going to do is restrict the domain of the red graph, y equals the cosine of x, so that its inverse is a function. That is, so that it passes the horizontal line test. If red passes the horizontal line test, then blue will pass the vertical line test. There are three criteria that we want to make sure are held true. The first is the domain should include all angles between 0 and pi over 2. This is useful because we're often using inverse cosine when we are solving right triangles. So that would include that portion. That means we must remove the following. Again, red must pass the horizontal line test so that eventually blue will pass the vertical line test. So we need to then remove all portions that are above the x-axis. I'm just leaving this here as a ghost. Imagine that we've erased it and then we can just see a little bit what's going on where it was. Now this is the only portion above the x-axis that's left. So on the restricted domain, the function should take on all values. Basically that means we need to get something, one of the portions below the x-axis. And which one are we going to take? Well, why don't we, since we're including this one, we'd like it to be continuous, so why don't we take this one? So that's the only interval that satisfies both 2 and 3, so we now need to take away all of the other parts that are below the x-axis. So this portion of the graph right here is the only one that satisfies the three criteria. So we call that y equals cosine of x on the restricted domain. Reflecting y equals the cosine of x on the restricted domain over the line y equals x results in the graph of the inverse cosine function, or y equals inverse cosine of x. When we reflect red, we get blue, and that is the graph of y equals the inverse cosine of x. If we look at these two graphs separately, and we can see the domain of y equals cosine of x on the restricted domain is 0 to pi, so the range over here is 0 to pi. The range here is negative 1 to 1, so the domain here is negative 1 to 1. This graph over here includes the point 0, 1, this includes the point 1, 0, and so forth.